Alright guys, so let's try this past paper with the same simultaneous equations. We're solving it using the matrix method. Alright, so that's like we learned from the last video. So we have a simultaneous equation here, right? So it's already uniform, ax plus by is equal to c, and both of them, so we know how to rearrange it. So let's get uniform. So the first one, we need to get the coefficient matrix. So we have 2, 3, and minus 5, and then, well, 1. So there are two unknowns here, which is x and y. That didn't change. And the constants here is 5 and 13. Alright, so now we can name this A. This would be x. And that is equal to B. So therefore x will equal to, and like we learned before, the A inverse by B is the only one that was compatible. Because B by A inverse wouldn't be compatible. Right. So we obtain the equation. So obviously we're seeing that we don't have A inverse. So we could go and calculate A inverse. Remember, A inverse is 1 on the determinant of A multiplied by the adjoint. So the determinant of A is equal to AD minus BC. So this is A here. So this is A, B, C, and D. So A by D is 2 minus B by C. So that minus, and B by C is minus 15. So we end up with 2 plus 15, which is 17. Alright, and then the adjoint of A. So together we interchange A and D, so it's be 1 and 2. And we change the signs of B and C. So B is positive, so be minus, and C is negative, so it's be plus. Right, so the inverse, putting it all together, just be 1 and 17 by 1 minus 3, 5 and 2. Alright, so that'll be the inverse. So we could expand it out, but we won't do that as yet. Alright, so now let's make some space. So we have the inverse. So now let's search where we can reduce it. So let's do the expanding parts. So now what we have, so that's if we expand it. So let's expand it out. So 1 and 17, then minus 3 and 17, and then 5 and 17, and then 2 and 17. So that would be the inverse. And you have to expand it out. Alright, so now all we need to do to get x and y is to x multiplied by b. So now we have x is equal to A inverse, which is 1 and 17 minus 3 and 17, 5 and 17, and 2 and 17 multiplied by b, which is 5 and 13. So that's equivalent before rows by column. So we have what's row here, and we have this row here, and we have this column. Alright, so let's go. So there's a 2 by 2, and there's a 2 by 1. They're compatible, and it will give us a 2 by 1. So 2 rows and 1. So we expect something here, and we expect something here. Alright, so it's set up already, so that's why I multiply. So 1 by that, 5 and 17. The second one by the second one, so minus 3 and 17 by 13, so that'll be minus 39 and 17. And then that is it for the first row. So the second row will be 5 and 17 by 5, if we do 25 and 17. And then 2 by 17 by 13 will be 20, so it'll be plus 26 and 17. So now x, remember x was xy, that will be equal to, so let's see, so 5 minus 39 is minus 34 and 17, and 25 plus 26 is 51 and 17. So the final answer will just be minus 2, and 51 divided by 17 is 3. So therefore, x will equal to minus 2 and y will equal to 3. Alright, and that's the end there. So that's the end. So that's how you get x and y using the matrix method. Alright.